11.1a, Homework Part 4. Solve the following system by substitution method to check these solutions. This y right here is already solved for, so y is equal to 4 minus 2x. Wherever I see a y in the first equation, I'll simply plug in 4 minus 2x. 2x plus y being 4 minus 2x, is equal to 4. We drop the parentheses, leaving us 2x plus 4 minus 2x equals 4. 2x minus 2x cancels out. 4 is equal to 4. That is true. If you ever get a constant equal to a constant, this is always true, which means these both have to be actually the same equation. We call this dependent. So these are dependent equations. Basically means these are actually the same equation. And I can prove that. For instance, the second equation is y is equal to 4 minus 2x. If I add 2x to both sides of this equation, I end up with 2x plus y is equal to 4, which is the same as the first equation, which is 2x plus y is equal to 4. So this actually ended up being the same equation, just in a different form. And you know that whenever you solve, you'll end up with a constant equal to a constant. Either it's going to be the same constant, like 4 is equal to 4, or if you do a lot more work, it might be a 0 is equal to a 0. But whenever you recognize that both of these are going to be equivalent to each other, you can stop, and that's a dependent system of linear equations. Solve the following system by substitution method. Check the solution. This x right here is already solved for, so I'm going to use it. Wherever I see x in the first one, I'm going to plug in 8 minus 5y. 3x, where x is equal to 8 minus 5y, plus 15y is equal to 4. 3 times 8 is 24. 3 times negative 5 is negative 15y, plus 15y is equal to 4. Negative 25y plus 15y are the same, so they cancel out. 24 is equal to 4. Now this is almost the exact opposite of the previous one. Whereas the previous one, 4 was always equal to 4, so they are dependent. In this situation, 24 is never equal to 4. Different constants are never equal to each other. 4 isn't equal to 3, 0 isn't equal to 5. Two different constants are never equal to each other. So this is never true, so we call this a inconsistent system of linear equations. Now, that basically means there's no answer. So no answer. So it's never true, so there's no answer. The previous one is always true. Since these are equivalent to each other, there's nothing you can't plug in the first one that's not going to make the second. This is going to make the second one not true. So everything will make the first one true, will make the second one true, because they're the same equation. So I can't have the same equation, plug in the same number, and get two different results. Okay? So this is always true. So there are an infinite number of infinite solutions. Okay? So negative infinity to infinity, all real numbers. Okay. The last one, solve the following system by substitution method. Check the solution. In this case, we have a 3y, we have a 16x, we have a 5x, and we have a negative y. That negative y actually has a negative 1 coefficient, and that'd be the easiest one to solve for y. I need to get that negative y, or subtraction y, by itself, so I have to get rid of that positive 5x by subtracting 5x, and whatever I do to one side, I do to the other. Those cancel out, leaving me negative y is equal to negative 5x minus 2. Next, I don't want a negative y, I want a positive y. So I'm going to divide everything by negative 1, and that will give me positive y is equal to positive 5x plus 2. Now that I've solved for y, I know y is equal to 5x plus 2. I'm going to plug it into the first equation, and wherever I see a y, I'm going to plug in 5x plus 2. So 3y, well, y is equal to 5x plus 2 is equal to 15x plus 6. I'm going to do some distribution. 3 times 5x is 15x. 3 times 2 is a 6. 15x plus 6. And this is what I was referring to before. I can continue to try to solve this, but I've already recognized that obviously 15x plus 6 is equal to 15x plus 6. So we already know at this point these are dependent. They're infinite answers. And all real numbers are our answers.